Okay, Shabab. So we said what is acceleration, as you said, is a change in velocity. How can you have a change in velocity? We said before velocity is a vector, so it has magnitude which equal to the speed, and also it have direction. So any change in speed by speeding up or slowing down, or a change in direction, moving right, then moving left, moving in a circle. So all of these leads us to acceleration. So an object accelerates when its velocity changes. That is when, how the velocity change, when it speeds up or slows down, or it changing speed. But, and also because it is a vector, you can change what direction. So in these three cases, we could have acceleration. Okay, now you can watch a video about this concept. I have here many videos, but I'm searching for a certain one for you.
Have you ever wondered, when driving a car, why you are pushed back into your seat when the driver hits the gas pedal? This is because the car is accelerating and your body isn't. Your body is slowly catching up to the speed of the car. In this video, we're going to look at different types of acceleration and compare acceleration in different experiences.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour, and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence, the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator, and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction. There are many more important concepts about acceleration, which we will cover in the coming videos.
So as you watched in the video, that we could have acceleration. She talked about many things in the video. One of the most important things, okay, is what we said about changing in velocity leads us to acceleration, okay. But what is the new thing from the video? What is the new thing you got from this video? Who can tell us? Does this video have new information? كشري سنبل وباشي إبراهيم يوسف إبراهيم سوري عبد الله يوسف عبد الله إبراهيم. Okay, Ahmed Bajaba.
Yes, miss.
Yes, Ahmed. Can you tell us any new information from the video?
The new information.
Did you watch the video?
It was talking. Yes, it was talking about velocity.
Did you watch the video? Yes or no?
Yes, mister.
Okay. What you got from the video?
The velocity when you turn like this, it will be different.
Okay, thanks. Ahmad Afif.
Yes, mister. I get the acceleration. The unit of acceleration is meter per second square.
Excellent. What about the law?
The law is the SV minus U over time T.
Okay, excellent. So, okay, thanks. So, Shabab, we said before, acceleration and change. Acceleration is a change in velocity, and we refer to change as this triangle, which we call delta. So, a change in velocity, and this change happens in a time interval. Okay, and if we draw a line of a moving object, if the object moved from A and to B, so it starts here with an initial velocity, we give it symbol VI, and it ends with a final velocity. We give it symbol VF. So what's happening here? It has two velocities. So during the change between these two velocities, in a certain time, we can have what? And if I say this, we have time here. So a change in velocity over time. So we can say acceleration equals a change in velocity over time. And the change in velocity before we refer it as what? Sorry, a change like this, like displacement, a change in position, delta xf minus xi. So the same way here, it will be vf minus vi over the time. Okay, so what is vf? Final velocity. What is vi? Initial velocity. The same thing we put in a change in position, which we call displacement, final position minus the initial position. Also a change in velocity, final velocity minus the initial velocity, and this change happens in a certain time or during a time interval. So in general, what is the law of acceleration? Acceleration equals change in velocity Vf minus Vi over time. And as we are from here, we can rearrange this formula as we used to do in many equations. Okay, so we can make cross multiplication. So this is the first equation, Shabab. This will be the first equation with us. We want to get a second equation. If we make cross multiplication, so Vf minus Vi will be multiplied by 1, right? Vf minus Vi multiply 1, so the same Vf minus Vi. And A is multiplied T. So AT. So we can move Vi to the other side, or we can just add both positive Vi for both sides, positive Vi. So we cancel this one as used to do. So what we get at final we get what? We get Vf equals, you can, I'll just bring Vi at first, Vf equal Vi plus AT. So from this equation, we can have another equation, this one. It's the same equation. 1 and 2 are the same equation, but just in case we need to use this form in other lessons, so, or in the same lesson, because sometimes it can ask you calculate the final velocity, or calculate the initial velocity, or calculate time or acceleration. So the direct equation, what is the acceleration? So a change in velocity over time. Okay, all these points are clear. What is the measuring unit? What is the measuring unit of velocity? Back we said acceleration equal change of velocity over time. And we know that the measuring unit of velocity is what? Meter per second. And the time also here is measured in seconds. So a change in velocity happens in a time. So we can move this one to the denominator down. Okay, so it will be meter over second times second, which will be meter second square. And in a simple way, we write acceleration is measured in meter per second square. Okay, so velocity is measured in meter per second. Acceleration is measured in meter per second square. Why? Because velocity it change in position over time, but acceleration it change of velocity, which is meter per second over time. So now we have two times, one from a change in position and one change in velocity. So we have here, so that's why we got second part. Okay, so let's revise what we said now about acceleration. The rate at which an object velocity changes is called acceleration. We give it symbol A, and the A is bold because it is a vector. As we said before, acceleration is measured in meter per second square. Like displacement and velocity, acceleration is what? Is a vector. And when the velocity of an object changes at constant rate, it has a constant acceleration. We'll discuss this point later. Acceleration can occur when speed is constant, but the direction of the object is changing. And that's what we said at the beginning of the session. When you change direction, you also have acceleration. And we'll have examples with number, how to know as a proof when we change a direction and we have constant speed. See here, it's constant speed. The object is not speeding up, it's not slowing down. But at the same time, we have acceleration because it is changing what? Direction. Okay. When the velocity of an object changes at a constant rate, it has a constant acceleration. What we mean by changes at constant rate? When the velocity of an object changes at a constant rate. You can see this one from the graphs, okay? Here, we will plot velocity versus time, velocity on y-axis and time on x-axis, as we did before. In a velocity time graph, velocity is plotted on the vertical axis and time is plotted on the horizontal axis. Okay, we said before, velocity over time. change in velocity over time. This equals what? Acceleration. So also when you have here a change in velocity and you divide over time, so you are calculating what? Slope. So a slope of velocity time graph, the slope equals to what, شباب? Equals to acceleration. So when you have a graph, like this one, but the graph is what? Velocity and time. In the beginning of our course, I told you how to read a graph. First, you have to look what is here. If we have position and the time, okay, you calculate a change in position. We give over time, so you are the slope will be what? Velocity. But here you are calculating a change of velocity over time, so the slope will be equal to acceleration. So pay attention which graph you are dealing. This position versus time or velocity versus time. Okay? You can determine the acceleration from a velocity time graph by calculating what? The slope, by calculating the slope. Okay, this is another point for acceleration. You feel that they are the same thing we did in the previous lessons, we did here for acceleration. Here you can see that the average acceleration, as we said, change in velocity Vf minus Vi over the time interval, Tf minus Ti, but in general we give you the time interval as one number. Okay. So what is the average acceleration of an object? Is the change in velocity during some measurable time interval divided by the time interval. Okay. But when I ask you what is the acceleration at 4, so now I give you an instant. I give you a direct number. So you don't have to calculate 2 points and find the difference. So it's just you just calculate by, if I told you when it was 4 seconds, what was acceleration, just to go 4, and we get here we have 16. So 16 divide 4 is what? You have to say it is 4, right? 4 meter per second square. So what you did here, you calculated the acceleration, but what's the difference? You calculated instantaneous acceleration. Why? Because you have only one instant at an instant at a specific time. So we call it what? Instantaneous. The change in velocity at an instant time is called what? Instantaneous acceleration. Okay. This is another point here in our lesson for acceleration. Okay, another point, how can we calculate acceleration of vectors, from vectors? How can we calculate acceleration from vectors? Look here, we have, this is the initial velocity and this is the final velocity. Remember the law, acceleration equals Vf minus Vi over time. So here Vi and Vf are in the same direction. This one in the positive direction, this one in the positive direction. So how can we find the acceleration? Go to the law, you can see that acceleration Vf minus Vi. Vf, we'll consider this direction is the positive and this direction is the negative one. Both are in the same direction. So, and Vf in the law, it is stayed in its direction, but Vf is minus. So what we have to do for this vector, we have to make it reverse in the other direction to have minus Vi. As you saw here, as you can see here in step number 2, Vf we keep the same direction, but Vi we make the reverse direction. Why we did this? To have minus Vi. Okay, and when we have vectors, what is the difference between Vi and Vf? Difference we can find where? In this space. This between the end of this one and the tip of the second one. Okay, so this will be delta V, what change in velocity, Vf minus Vi, okay, which we refer to acceleration. Okay, so if I give you any two vectors, like this one and this one, I say this is VI and this one is VF. How can you find the acceleration? By drawing, keep VF the first step, keep VF the same. Okay, the second step, we have VF in the same direction, make the reverse of VI. So make VI in the reverse direction. The third step, what is acceleration? Acceleration is the difference between them, these lines. So you have to write this one again, and here we have acceleration, which is delta V, this is delta V. And this will be acceleration after we divide over time. But the direction of acceleration here you can find it is to the right. Why it is to the right? It takes the direction of the bigger one. You can see VF to the right and VF is greater than VI. So delta V will be in the same direction and also acceleration will be in the same direction. And this leads us to an important thing. When we have when velocity and the acceleration have the same direction, it means the object is speeding up. But when acceleration and velocity are in opposite direction, you can say that the object is slowing down. Okay? So in general, how can you tell that the object is speeding up? When we have both acceleration and velocity are in the same direction. You look here to this one. Both acceleration and velocity are in the same direction. And how can we get, you have VF and VI. You calculate VF minus VI, so you get delta V, and this will be the direction of acceleration. So both acceleration and velocity are in the same direction. How you know the direction of velocity? This delta V. Delta V is in the same direction like the or the bigger one. Okay? And by numbers, if I said VF is equal to 10, and we have VI is equal to 5. This 5 meters per second, sorry, this 10 meters per second. So what you have to do, you have to keep VF the same direction, this VF 10 meters per second. And you have to find VI, which will be in this case minus 5 meters per second. Okay, so VF minus VI, it means 10 minus 5 will be 5 meters per second. So this will be delta V, and its sign is positive, so delta V will be here. This delta V. Okay, and so the acceleration will be the same after you divide delta V over time. So now we have the acceleration. So now the both directions are the same. This one is positive, this one is positive. So you have to know the object is what? Is speeding up. The object is speeding up. Because we are in positive direction, if we the movement in negative direction, and you also the same thing, there's VF to left and VI to right, so delta V would be the sign of the bigger one. Okay, so acceleration is negative, delta V is negative. So both acceleration and velocity have the same sign, So the object also is speeding up, but speeding up in negative direction. So like you are moving into right and your friend is moving to left. You choose right, so your direction is positive. Your friend choose left, so his direction is negative. Okay, we said before where positive and negative refer to direction. So here it doesn't mean in decreasing or what. Positive doesn't mean decreasing. It means moving in positive direction. Okay, pay attention and remember this point. So here acceleration and velocity have the same sign, positive and positive. So it's speeding up. Also acceleration negative, velocity negative, so it's also speeding up. When it is slowing down, if acceleration is positive and the velocity is negative, it is slowing down. Or the opposite, acceleration is negative and the velocity is positive. So it means both of them are acting against each other. Okay, how could this happen? Imagine you are moving to an electric signal, or sorry, a traffic signal on the street. So you are moving fast. When you see the traffic signal, you have to use the brake. So your velocity is toward the traffic light, but your brake are trying what? To make your car stop. So the direction of brake is backward. The direction of brake is backward, but the direction of movement is forward. So now acceleration and velocity are opposite direction. Acceleration here comes from the brake. Acceleration comes from the brake because the brake wants to make a change in the value of speed. Understand this point? The brake wants to make a change in your velocity of the car. So the acceleration, its direction is backward because the car is moving backward and now you want to slow down. So you are using the brake. Okay, so now the acceleration is backward and your movement is forward. So they are in opposite directions. They are in opposite direction. For these points, do you have any questions, Shabab? Do you have any questions here? What is uniform, non-uniform? Here, for this one, if you are going to a traffic signal, okay, you're going to use, you are moving toward the traffic signal, but you are using a brake. So the brake wants to slow down. How to slow down? By making the reverse action. So both velocity and acceleration have different signs. So the object is slowing it down. So we have also acceleration. Yes, Ryan.
Mr.
Mm.
If the acceleration is decreasing and the velocity is decreasing, that means it's slowing down or moving in the same way.
No. You cannot say acceleration is decreasing or decreasing. We use acceleration means what?
Change in velocity.
Yes, we didn't say speeding up. We didn't say speeding up. Understand?
Yes.
So when I'm trying to slow down the movement of your car, so it's also acceleration. It's also what?
Acceleration.
Acceleration. If we change direction, it's also acceleration. If we're speeding up, it's also acceleration. Okay? So in the beginning of the video, we said that there is a common thought that acceleration means increasing speed or moving faster, right?
Yes.
No, it's wrong. Acceleration has three different meaning. We can increase speed, it's considered acceleration. If we decrease speed, consider also acceleration.
Yes.
Okay? If we change direction, it's also acceleration. So you can see this one. There is a video here. Okay, this is a small video here. You can watch this one.
These motion diagrams. In one diagram, the jogger is motionless. In another, she is moving at a constant speed. In a third, she is speeding up. And in a fourth, she is slowing down. The most important thing to notice in these motion diagrams is the distance between successive positions. In this diagram, because there is only one image of the person, you can conclude that she is not moving. This diagram is like the constant velocity motion diagrams you have seen earlier. The distances between images are the same, so the jogger is moving at a constant speed. The distance between successive positions changes in the two remaining diagrams. If the change in positions gets larger, the jogger is speeding up. If the change in position gets smaller, the jogger is slowing down. Just as it was useful to graph a change in position versus time, It is also useful to plot an object's velocity versus time, which is also called a velocity time, or VT graph. The tables show the jogger's velocity at a particular time in different motion diagrams. Plot these data points on a graph to obtain the velocity time graph. The positive direction has been chosen to be the same as that of the motion of the jogger. Notice that the graph for the jogger speeding up is a straight line with a positive slope, which means that the jogger was speeding up at a constant rate. The rate at which the jogger's velocity is changing can be found by calculating the slope of the velocity time graph.
Okay, Shabab. Just one note before we leave. All of these resources you can find on your WinGgo and also MicroHelp. I make highlighted for you. You can study from if you want to study from your book. This is a PDF one, and for each question you have here's answer. Okay, you can download it from WinGgo. Okay, all of these things we talked about here. Inshallah, tomorrow next period we'll talk about how can we calculate all different problems from graph, okay, and also from this one we didn't talk about, okay, this is the only one we didn't take. We talk about everything, average acceleration instantaneous, okay, we talked about calculating acceleration using its law. Just we talked about everything, just 2 points. We want to start with the next period and then answering what questions. Okay, so this is what I wanted to see, to tell you that you have this PDF by this highlighted way in your manual. Okay, so yeah, WinGgo. I have put it for WinGgo. You have PDF, you have PowerPoint, you have videos, you have everything. Okay, thanks, Shabab. See you next period, inshallah. Assalamu alaikum.